Okay. Hi everybody, thank you for coming. So my talk today is entitled Automation Causes a Solution to All of Our Problems. If anybody gets the reference for that, there's going to be more references in a similar vein going forward. So the kind of basis of this talk is that a lot of the time in cybersecurity we talk about the malicious automation that attackers are using. Right? Oh, they're spinning up all these things in AWS and then automating this and automating that. But really, whenever attackers are doing all of that stuff, whenever that hits, the blue team, whenever it hits the scene, whenever it hits those other technologies, it tends to generate like a couple of alerts, right? So if we think about, well, what is generating all of the alerts that we're handling all of the time inside the SOAR or inside security operations? It's not attackers. So what is actually going and doing it? So we have the malicious automation, which is assisting attackers. And then we also have our own automation on the blue team side, right? That's attempting to try to make our lives easier. But the thing that's actually causing most of our alert fatigue is as a consequence of bad automation that is internal to our organization, that's doing some other function, and yet is also performing some sort of activity that looks similar enough to something an attacker would do. That's what's causing all of our fatigue. So that's what this is about. Did a little slide on me, but I've already been introduced. So yeah, just a little more on me. This is my fourth B-side presentation, I think. And then that's me presenting at Big Data Belfast, although that's one pandemic and 2 stone ago. So just a quick poll, because I know you love raising your hands. Who here suffers from alert fatigue or works in a team that suffers from alert fatigue? That's pretty good. There's some vociferous ones at the back. They're very fatigued. Okay, yeah. So ultimately, in the end, that hasn't really changed. So if we look back on the history of the industry, way back, right, so 15, 20 years, right, then we still had alert fatigue then, we still have alert fatigue now, and yet we have all these other tools that have turned up and then said we're going to solve it, and yet here we are, right? So what is actually generating that, right? Now, one of the first things that I wanted to talk about was AI, right? And I like to describe AI as a wolf in granny's clothing, right? It makes a good story, but it's definitely not what it pretends to be, right? It's not actually what it says. So we've seen this before, right? The security industry is replete with companies turning around saying, "I've got a new technology that will solve your problem. I've got a new technology that will solve your problem." And yet we sit here with the same problems that we had 10, 15 years ago. So maybe technology isn't actually the problem. Whenever this goes on and off, can you still hear me? Yeah. Yeah? Okay. So, if we go back, far enough back, right, then what kind of technology, what kind of detection technologies do we have in order to try to help us? Right? Let's go through a bit of a background. So, signatures, just basic signatures. Right? Let's write some logic. If some sort of data matches that particular signature, well then, fire an alert, right? Okay, pretty simple. Back then, people saying, these signatures are terrible, we've got all these false positives, they're going everywhere, we need something else that's going to go and fix it. Okay, so they said the scene was dead, and they also said Manchester United would constantly win the Premier League, so that tells you how far back that was. So we said, okay, signatures, very bad. So what are we going to do? We're going to have anomaly detection. That will solve that problem, because ultimately in the end, if everything that an attacker does is atypical compared to the environment that they exist in, then ergo, that's going to be much more successful, right? Which can only really be said by people who have never worked with either networks or users before, because anomalous things happen all the time in a sufficiently large environment, right? The difficulty being that you couldn't really tune them, because it was a matter of saying, okay, well, it's going to reach a threshold somewhere. Okay, well, can I tune that? You can change the threshold, yeah, but I don't want to change the threshold. It's just doing certain things and generating false positives, but how do I tune that? It's just kind of doing anomalous things, right? So they said, okay, well, past anomaly detection was the next big thing. The next big thing is machine learning, right? And only we got yet more false positives, just nobody can really tell you why. The black box, okay, system learned something, it says that this thing is bad, great. Why did it say that? Well, I don't know, it just says that it's bad. Super duper. Right? So we got to this point, and yet we still have alert fatigue, right? I mean, this isn't fairly, it was fairly recent, but when we got to sort of machine learning component, people said, oh yeah, that'll fix all the problems. I don't think any of us could say that all of our problems are fixed, right? The only good thing, or one of the good things about machine learning is it rebrought signatures, but in reverse, because the only way to stop it generating all those alerts was to whitelist it, which is just a signature in reverse. So now we have Gen AI, right? And that's being posited as the thing that's now it's finally going to solve all our problems, right? But Who knows what we're going to get? Hallucinated false positives, things that have literally never happened, just being generated. Who knows? We'll see. Right? But I don't think any of us could say that this technology is going to be our savior. Right? Now, if we think about this from a more basic perspective, right? And again, try to get to the point of what was the actual cause of all of this to begin with. So, if technology isn't going to fix the problem, well then, what would? Right? So, if the signatures aren't the cause of the problem, they're just one of the tools. So, if we say the signatures are, say, a hammer, right? Then, if I give that hammer, that tool, to someone who either doesn't have the time or doesn't have the skill in order to wield it effectively, well, then you're going to get false positives. That's how that's going to end up working. So, for example, if I gave that hammer to my kids, well, then the house would be a mess. They'd probably take my kids off me. So, that's what you get if you give a particular tool to someone who isn't able to go and wield it. Now, we then continue on to the analogy. We've got anomaly detection, right? So anomaly detection isn't a replacement for a hammer. Nobody ever built a screwdriver good enough that it made all hammers obsolete. So it's another tool to solve another problem in a more effective way, but it doesn't replace any of the things beforehand. They all need to be there, right? Now, if we continue with that, then we have machine learning, right? Let's call that a SOAR. Why not, right? Now, if we talk about Gen AI is really just a larger extension of machine learning. So say that's a power saw, right? So then that's a power saw, and then that's going to make us much more effective in the things that we do. But if you think about the damage that you can do with a hammer, like if you think, well, how many false positives could you generate if you only had a hammer? Like, what bad things could you do? Well, say you had an electric saw. Say I give an electric saw to one of my kids, right? Well, then it probably wouldn't be much of a house left at all. So, what is the solution to that problem, right? The solution to that problem is this unit, right? So, ultimately, in the end, the problem has never been technology-based. The problem has been human-based. The problem has been business-based, right? It's about trying to generate a scenario whereby we have sufficiently trained staff who are able to wield these tools effectively in order to actually address the false positives and the alert fatigue that we've got in there, right? Because in the end, these are just tools. If there isn't a person to carry them around, well, then they just be hanging on the floor. So, this is the solution to the problem, not yet more technology. So if you say, okay, well, Gen AI is going to be, this speed, right, great, but it's still not going to solve the problem because somebody has to pick it up and use it, right? And that person who's picking up and using it is going to dictate how successful whatever it is they're trying to go and do. So, like I said, didn't take long. So this is kind of the scenario we've ended up with, right? We have created enough automation and let it loose inside our environments and not paid sufficient attention to what it is that it is doing, that it ends up causing us problems further on down the lane, right? It is, to a certain extent, in charge of a lot of the detection, a lot of the decisions that are being made, and we take that away from the humans who are supposed to be making these decisions, right? But we have to do that in a way whereby the humans are still in control and the humans are still involved in the process, and not just say, hey, let's have all this automation just run amok, right? And we'll talk about an example of that later. But anyway, let's talk about automation generally speaking, right? So, good automation that we like, right? What does it allow us to do? So it allows us to respond to events in near real time, it allows us to process very large volumes of data all at once, and it allows us to reduce human effort and repetitive tasks. And that's a good thing, right? As long as that's driven by human knowledge and human expertise, well then, great, right? It's harder to do than it sounds, but that's still objectively a good thing. Now, if I think about bad automation, right, you can take exactly the same concepts and then turn them evil, right? So instead of responding to things in near real time, what you end up with is the incapacity for a human to intervene. So the machine's just going to continue to go off and do what it does. By the time a human has been able to react and correct and do whatever that, or fix whatever it is, it's already done, right? Already done, perhaps even at scale, right? So the fact that you can do things at scale is good, but the fact that you can also do errors at scale isn't particularly helpful, right? So if you do it badly, then it's going to end up being much worse than if you hadn't done it at all. And then one of the things that I tend to see in practice happen an awful lot is because there's so much automation that's set inside the environment and then left, and then maybe somebody left, and then there wasn't really a proper handover, so then someone else is given responsibility for it, but then they don't really know what it was because they didn't build it, etc., etc. You end up with this reduced accountability. So if you have something in there that's doing something that it's not meant to, you say, well, hang on a minute, who's responsible for doing that? Everybody looks at each other and goes, I don't know, it's Gary, he left a year ago. Okay, well then who's responsible for making sure that either didn't cause a problem now or isn't going to cause future problems in the future? Well, I don't know, we should pick somebody else and try and work out how all this works again. Well, that's bad automation, right? And again, that's nothing to do with the technology. One of these things, you can get this bad component nothing in technology just does what it's told. But depending on the humans are managing it, well, then that's how you get something bad, right? Now, if we're trying to think of examples, in the recent past, we may have had some kind of automation, which isn't malicious automation, it's perfectly benign automation, does a perfectly good reason, or a perfectly good job for all of us, that may have caused us some trouble in the recent past. Then you can kind of see where this, where this can lead to, right? And one of the big things about, some of the outcomes from the CrowdStrike stuff, right, is the chances of this happening again are pretty high. Right? Because whilst CrowdStrike are one of the biggest companies in the world, their particular demographic, I mean, these are all things that are as a consequence of an over-reliance on automation and too little involvement of humans in validating the automation is doing the things it is meant to. Like, the automation didn't know that whenever it ran and it passed all those tests that it wasn't meant to continue. Like, a human would have done it and then said, that blue screen's probably not good, probably should have stopped this and then have another test, right? So, in the end, we do have to leverage automation. We do have to make sure that it continues to make our lives better, but we don't have to turn over all of the keys over to automation and just have it do exactly what it did there. So, So we'll talk a little bit about some of the different automations, some of the bad automations that you've got inside security operations, which ends up then consuming an awful lot of our time, and then talk a little bit about what we could potentially do or what tools are available for us to try to fix it. So, scanning discovery, right? A lot of people will be familiar with this, right? So, we'll start off with the scanner, right? Just the basic premise of the scanner. So, it's calls. Lots of scanners. Calls a day. So, the scanning is good, right? We like scanning. Scanning is good. It tries to identify whatever vulnerabilities or whatever risks exist inside the environment and then tell us about them. You don't want to be logging into every computer yourself to work all this out, so it's good automation from that perspective, right? But it's only good from a security blue team perspective if it's scheduled and known, right? If it's unknown, well, then that's the kind of thing that needs investigated, right? If it's unexpected, well, that's the kind of thing that needs investigated. Objectively, if you sit inside the blue team and someone says, well, we have an unexplained scan, should we look into that? You go, yes, we should. But it will probably be Qualys or any other scanner. Right? So the question is, how do we keep those components off our radar? Because they're just a reality. There's good automation, but some bad components out of it. Another example of this as well is asset discovery, right? Which is kind of different from scanning and also kind of worse way. So the purpose of asset discovery is to try to identify all the different assets inside the environment and then build that into like a CMDB so that people can access it and say, okay, well, here's all the stuff we've got in the environment, right? Jim brought a new printer and plugged it into the network, right? Jim, why'd you do that? But you have to actually find the printer first in order to go and shut it down. So the way that this causes a bigger problem is that it isn't actually, it's a lot more difficult to establish exactly where this asset discovery is going to be coming from. It doesn't necessarily always come just from the set of devices you've got inside the environment. It can actually come from other devices inside the environment because, again, asset discovery is about trying to find the other things you don't necessarily know about. Right? So it also then tends to have a more ad hoc running pattern. If you've got a scanner, you might scan, say, on a Saturday, okay, or last thing on a Friday, no problem. But ultimately, in the end, if you're doing something like asset discovery, we can't do it on a regular basis, then if something is constantly turned off on a Friday, well, then you're not going to know it exists. So it's much more ad hoc from that perspective. And it can also then carry out activities inside the existing devices for software enumeration and things like that, which then causes even more difficulty. But we're just talking about network scanning and network discovery, right? So why is that a problem, right? So this then defines your noise floor, right? So your noise floor will then dictate how can you actually detect unexplained scanning. So if you have constant scanning, constant asset discovery going on, then this is where your noise floor is, right? You've got your outside voice on constantly. Now if you have an attacker coming in, and the attacker is using their whisper spy voice, right? Well, then you're not going to hear that, because everybody's constantly shouting and using their outdoor voice. So this is the consequence of that, not just from a security perspective, because even if you've got a SIEM or some other technology and you think, okay, well, we're getting false positives, it's coming out of this scanning and asset discovery, well, you might be able to tune that in the SIEM, right? You're lucky. But it's still inside the environment, right? So if you find yourself in an IR perspective where you have to go and look through all of your data, all that data is in there, right? So one of the consequences of having this scanning, this asset discovery at the rate at which it is being performed inside the environment is that you're raising this noise floor to wherever it is. And then anything below that noise floor, well, you're not going to be able to spot it, right? And then even if we were to take some of our more advanced tools, right, if we were to say, okay, Gen AI or machine learning, please, learn what's going on in the environment, well then, this is what machine learning is going to do, right? So, if it's unexplained scanning is happening constantly, well, it's not unexplained anymore or unexpected. So, there's just lots of scanning? Yes, there is lots of scanning. So, well, how does that help, right? So, I'll talk about potentially some ways that we can try to combat that later. But even some of those more advanced tools, logically speaking, from within that set, it's going to be very difficult or impossible for them to say that it is atypical or something that's not expected. Now, one of the ways that this becomes even more difficult, right? This is a bit of a difficult picture. So, this is also from Service Line Discovery, right? So, say you have this mid-server one, right? And it is attempting to do cloud discovery from inside the network, right? That's the way it works. So, you've got an asset discovery server. Asset discovery server says, okay, I'll just discover assets in here. If you've configured it to also look for cloud assets, it'll go no problem, and I'll merrily scan the cloud for you. But inside the network, you can usually find out, because it's going to be happening inside the same network segment. But whenever it attempts to then contact, say, AWS or Azure and those other things, right, you're doing it this way. Well, then as it traverses through the network, right, any number of points there, you might lose the originating place. You might go through some sort of WAN. It might go through any number of things, right, that would strip the original origin. So when the request appears here at the firewall going out into the AWS, right, not unreasonable for some security system to say, hang on a minute, out of the blue, something inside the environment attempted to just contact this AWS IP address that it's never contacted before. That's a bit suspicious. And you go, yeah, that is a bit suspicious. Okay, let's have a look at that. But whenever you come and look in the firewall, right, you're only going to get the next hop. So where'd that come from? Load balancer. Okay, load balancer. Where did that come from? Oh. Okay. So you go further back, if you're even tracking that piece of information, right? It's quite common, in fact, to be tracking information here and tracking information here, but everything in the middle, not so much, right? So in the end, you have to go almost probably discovery and then come all the way back here in order to try to find it out. Or, like somebody said in the previous talk, you just do a short close. You go, oh. So, so this is also a problem you get from it as well. And then that can generate not just noise, but it actually, triggers detections for suspicious, CNC columns out to unknown AWS addresses. Yeah, it kind of does. Okay, so what can we kind of do about some of these things? So one is to attempt to aggregate the scans over a larger time period, right? Rather than say, okay, we've got the scan, let's look at this scan, let's look at it. Actually, if you widen up your time period to, let's say an hour, then from that given source location, sometimes the combination of queries or the combination of ports that it uses are fairly constant and can be used as a kind of signature. And then from that perspective, you can identify, okay, well, in that time period, I'm going to call that scan this thing because it matches an upload those criteria. If an attacker is doing something else, well, then the chances are it's not going to do exactly the same things as whatever you've got configured to go and do. So, there's no way to tell. Another one is canaries. So, people are generally aware of canaries. So, the basic premise of this is you get a token, a canary token, or a canary device inside your environment, and then you whitelist it from all of your scanning of everything, and you say, do not scan that, right? Now, from that perspective, once an attacker comes into the environment, they don't know not to scan that, so it's going to scan absolutely everything else, hit the noise floor, but then they'll be the only ones that scan the canary. So then you go, hang on a minute, who scanned the canary? Now, again, inevitably, the actual people hitting the canary in practice will be that admin. It's like, I wonder what that IP is. And you go, please stop doing that. But that's one way in order to try to reduce and get that noise floor away, and instead try to focus on things that are actually unexpected inside the environment, because you've made a decision that this is supposed to be unexpected inside the environment. Another one is enrichment, right? Now, that comes back to the asset inventory. So bad asset inventory, but whenever if we have it, well, it'll probably be quite helpful to try to work out what things are. So if you do have that kind of asset inventory, using that to enrich whatever's going on, if you can configure that inside your scene or inside your SOAR, or we'll talk more about SOAR later, then that can help. The more information enrichment you've got, the less lookups you've got to go and do, the less lookups you've got to go and do, the quicker you move through your queue, and the less onerous these alerts will seem to be. Then the last one is to be in the room, even for things you think are not security tools, right? So if you're a security team, right, well then obviously if there's a new security tool, you'll probably be involved in the rollout of that or some sort of, or decision making on some component. But also be in the room for other tools, even if they're not security related directly. Because again, if we think about, say, service line discovery, right, it's just asset discovery, it's got to do with security. But one of the consequences of that are the increase in noise floor. One of the consequences of that or we may end up having to go and investigate a lot of this stuff that looks an awful lot like suspicious scanning. So let's have a conversation right at the start about, what are the consequences of this, right? Can we configure this in a way that is more effective? And the only real way to do that is to be in the room, right? So don't just let the organisation run off and do its own thing and then say, okay, we'll do our thing, they'll do theirs. In the end, a lot of these tools are owned and operated by other people or other departments inside the estate. So if you partner with them, you might be able to take the edge off some of this. Okay, so that's scanning assets. Next one's emails. So, again, the point of this is to do bad automation, not malicious automation, but if there is a domain whereby malicious automation vastly outstrips the defenses, it is in phishing and email protection, right? So, I'm not even here to talk about URL rotation, URL delay, use of captchas so they can't be scanned, redirects so that the security systems aren't assessing the correct domain that's actually going to be served to people. None of that, right? That's not even our problem here, right? One thing that we've got that's bad automation, right, is it's called cold email domain variation. You can see this quite a bit, right? Now just for people's purposes, cold email spam. So the way that this works, if I am, say, this middle address, well, let's see the bottom address. So if I'm the bottom address there, and I send, 100 spam emails, the chances are they're not going to get blocked to begin with. The chances are your email protection system is going to say, okay, let's read the first 50. Then it'll be like, that's quite a lot of emails, that's probably spam. Let's mark it as spam. All right. So you send 100 emails, 50 of them got through. Right? Well then, if you just use automation, right, in order for this cold email delivery, right, then you just change the sender to be that. Okay? And this is all done in an automated sense. So again, then the spam system is going to get that and then saying, okay, hang on a minute. No, about 50, I think this is spam again, I'll stop that. Okay? But out of the two of them, you got 100 delivered. Half of those and half of those. And even if it starts to learn and say, hang on a minute, I'm a bit suspicious about this domain, it's still reduced to a certain component. So instead of 50-50, you might get 50-50-40. And then that'll give you some level of deliverability inside it, right? So this is one way that you're going to beat these, get past any of the spam protections, right? As you start to vary those. This is all automated. Now, you might think, well, okay, we'll just block the domain, genius. Yeah, okay, but obviously they've thought of that. So you start off with this domain, right? Well then, again, from an automated perspective, and all this, the entire thing is automated. So you've got that, just add .co at the end. Okay, well then you haven't blocked that domain, right? It's a completely new domain. So, okay, and then the next one, .email, the next one, .net. And again, each of these is going to let 50 through. 50, 50, 50, 50. Then again, you don't have to just be doing the TLD. Just add a couple of extra letters on there. ER, ING, do all that. Yep, no problem. Then you can combine them. So you've got outreacher.co, outreacher.email, outreacher.net, over and over and over. Each of those, maybe they'll get 50 to go through. Now you combine that with that one. And you're starting to vary the sender and the domain in a way that, how do you stop that? Right? So most email protection systems aren't able to, in order to defeat this. So, now, I talk about spam, right? Now, why is spam a problem? Spam is a similar problem from a security perspective as the noise floor is a problem from a security perspective, right? Because in the end, whenever users receive these, they still then report a certain component of them to the security team. They still say, hey, security, what's this about? Well, it's clearly spam, but okay. So you have to have a look at it and then say, no, that one is spam again too. Okay. Now, that is a problem from an alert fatigue perspective. You might find that from certain scenarios, then all the things are reported from an email perspective to security teams end up being spam. But there's also a fatigue perspective from users, right? So if I go to the average user and then say, hey, I'm going to send you 100 emails, one of them is a fish, you tell me which one it is. Chances of them doing that slim compared to if I say, tell you what, I'm going to send you 5 emails, one of them is a fish, you tell me which one it is. Okay, well then they're going to have the stamina in order to try to assess all of those and then go through it rather than thinking, not another one of these. So the more spam that they receive, the more spam is reported to security teams, and the less likely they are to spot actual problems. Now, in terms of the variation of those senders and the domains, right, well, how are you going to solve that? Right? Now, there is one crowd that I've seen that does something that's quite nifty, right? And you'll have to dust off your GCSE French for this one. So, these guys, whenever a new sender is observed coming into the mailbox, the email isn't delivered. Instead, what happens is the sender gets an email that effectively says, complete this captcha. You have to prove that you're a person. And then after you complete all that, only then is your email allowed to be delivered. And then going forwards, then your emails are delivered because it confirms there's an actual person there. And that doesn't solve all problems, and certainly what it does is it slows down new contacts, because you still have to go and do this. And as you would imagine, if you send an email to somebody and then they get this back and then they immediately report that to the security team and then say, what the hell is this thing? Right? But it does nonetheless work, right? So it would solve that particular cold email domain variation problem, because as they start to vary, well, it's not going to solve CAPTCHA every time, so they're not going to get through. So it solved that particular problem, although maybe not all of them. So this is some good automation that you can have, right? This type of approach is one that can try to combat that spam problem, and ultimately the security problems that come with it. Okay, sandboxes. Now, sandboxes are good. I do like sandboxes. Sandboxes are one of the more effective ways that security professionals can deal with potentially malicious like artifacts and files and links in a way that is safe. It's quite cost effective in order to get people access to these and to try to learn, try to use them. Now, there is a certain amount of skill that still comes into assessing sandboxes and using sandboxes, but nonetheless, they are a component of good automation, right? But they can also be used for bad automation, right? Now, different things that a sandbox does. I'm not going to do this in any detail. We're not here for sandbox analysis, but you've got static analysis and you've got dynamic analysis. Right? Static analysis, just signatures. Dynamic analysis, call anomaly detection. Right? So from that perspective, this kind of stuff is kind of predictable. This kind of stuff is not kind of predictable, right? So if you're going to be taking a piece of technology and then putting it in an automated perspective, I think it's fine to then either be very prescriptive about which of these static components you're going to rely on, because again, if you're a human, you're making a decision, you're making a business decision that I'm going to do this thing, and I'm going to automate it, and as a result I'm going to stand over the consequences of it. Then, but from the dynamic analysis perspective, you don't necessarily know what it's going to go and do, right? You don't know what it's going to pick up and what it's going to say is good or bad. So you end up in a scenario where you've got something flagged as malicious, but of course, like, is it? Like, the sandbox says, oh, this is bad, whatever, this is setup.exe, and does all those things, right, great. But is it? Like, you require a human to come and look at this and then assess it and go, like, well, hang on a minute, sandbox, what are you talking about? Because the sandbox is completely devoid of context, it doesn't know. So if I have loaded an Excel sheet into the sandbox and execute, and it goes red and says, there's macros in this. Well, there's meant to be macros in it, it's a macro sheet. That's what's stored, and they go, oh, we're okay then. Well, it requires a human to know that, like the sandbox is devoid of context, it doesn't know why that's happening. And say, oh, hang on a minute, this one's also writing 10 files. It's meant to write 10 files. Well, this triggers edge.exe. How else would it view the web page? I mean, that's how this works. So, the thing about this is, if you rely too heavily on the decisions that are coming out of these sandboxes, then you end up with far too many false positives, and then this is what ends up causing so much of our alert fatigue, right? So, if the sandbox says, I consider this to be bad, right? There's too many scenarios, particularly in open source intelligence or even certain threat intelligence feeds, that'll come along and then say, okay, well, this is malware. Everything that this malware does therefore must be bad. If it checks the time, things that check the time must be bad. Well, no, obviously not, right? Not everything that malware does is inherently malicious, and not everything that a malware does need to be reported upon. And yet, for years and years and years, when if I go into particularly open source or crowdsourced or community-sourced threat intelligence feeds, you'll find, well, hang on, where did this come from? You go all the way back and you said, oh, somebody just put that into automated the consequences of that being submitted into or the consequences of the analysis being submitted into that OSINT feed, and then I'm going to remove that false positives, it causes all these problems, right? Now, like, inside security, you have to have a certain amount of skepticism, right, about pretty much everything, but particularly where you have a computer. If a computer is telling you something, under no circumstances, you just be like, okay, yeah, that's fine. Like, one of the first things that I do tell, more junior analysts whenever they start is that the computer says this, or the security system says this. Do not believe it. Use your human brain. You're not there to just say, well, the computer says no. That's not what you're here for, right? So the more we can encourage and train and develop people, right, be that big blue unit guy, right, rather than just being somebody who's just slave to the tools. Now, back to automation. How do we turn this into good automation, right? So to a certain extent, it is bad automation, right, because it does lead to these false positives, it does lead to these false impressions about the maliciousness of stuff. But, so I've stolen this, right? Now, this is about team dynamics, right? People know this, forming, storming, non-performing, right? Now, where do you think you should automate? Where in whatever it is you're doing, the project or the system or whatever it is you're trying to design, where do you think you should be automating? Most of the time, business imperatives would impel you to try to do all the automation here, right? And that's your bad automation zone. Because whenever you're trying to do whatever this thing is, right, you have an idea, then you put it into practice and find you're wrong, and then you fix whatever you were wrong about, and then you go, okay, let's try to go and optimize it. So this is your time, right, for automation, right? You've decided you know actually what's going on, you're trying to find out how to optimize it and get it as good as it can be. Okay, well then, let's try to see if we can automate some components of that, because we've now proven over time that it's actually worthwhile doing. Great, automate here, don't automate here, right? And that's difficult to do, because like I say, business developers turn up and say, oh, hang on a minute, I've got this AI thing, so this AI thing should be able to automate all these bits and pieces. So I want you to take this AI thing and solve that problem. Well, we don't really understand the problem. Let's see if we can go and do like even a small component of it and like do it, not even by hand, but like just with normal tools before we automate. No, it has to be done quickly. It has to be done last Friday. In fact, I told the board it's already done. Okay then. But let's try to, the more we can fight against that, the more we will stop to generate bad automation, right? Because bad automation ultimately ends up costing us more further on down the line than if we just take the time in order to truly understand the problem and then automate whenever we're trying to move from norming into performing rather than right at the start. And the other thing that can help in this perspective is making sure that there's still a human in the loop. So, interestingly, I used to use this slide sort of many years ago, and there that used to say ML model. Now it just says AI model. So whenever this comes in, right, whatever it is that you're doing, doesn't matter what it's doing, comes through this chain, right? And then whatever technical system you've got will have a certain confidence level. And if it doesn't have a confidence level, well then unfortunately you're going to have to work out what components of things that it does you have confidence in and infer that yourself. But if the system doesn't have a certain amount of confidence, involve the human. Like, if you have too much automation that is allowed to run amok by itself without any human involvement, that's where you get into scenarios where, like CrowdStrike, right? Like, I don't work for CrowdStrike. I don't particularly know anybody that does work for CrowdStrike, but I would be shocked if there weren't people inside CrowdStrike that could say, yeah, we had a couple of near misses that were just like that, right? So, if you were to include a human in the loop as part of this, right, well then, the human might be able to identify what's going wrong here. And I would also suggest that from this perspective, even the things that you're saying, okay, well, look, I've looked at this, I've understood this problem, like, if something is very low confidence, it'll involve a human, but even if it's high confidence, I still want to QC what's going on in here, right? So even from a sample perspective, take a certain amount of things that are in there, and then once a week, once a month, once a quarter, take 5 of them and then have a human look at it and go, is that still doing the thing that it's meant to go and do, right? There's this fallacy that you'll hear in terms of like, well, who's complained is probably okay. No, you're just continuing to pile straw on top of the camel's back. Then one day, one will be too much and the camel will fall down and they'll be able to say, did you not notice that the camel was overloaded with straw? No, because nobody was looking at what was going on. If it was coming out here, we just blindly believe the automation. Right? So I would suggest that we don't do that. We try to reintroduce the human into the loop here as much as possible, even if it's not in the critical path, right? But even from a sampling perspective, and then say, well, humans just at least going to check that it's doing the thing it's meant to. Okay, so a couple of other examples, but I'll talk about this very briefly. Other examples, right? So you have SCCM. Other talks talked about SCCM earlier. So other things that can then cause bad automation and then trigger security systems, right? So copying exes or .hca files around the internal network looks a lot like lateral movement. Right? Terraform and AWS is one, right? Spinning up assets from an automated perspective looks a lot like coin mining or resource consumption. Pretty much anytime Ansible uses PowerShell for almost anything, people go, hang on a minute, what's that doing? That's not me doing that. And you find it's Ansible. Patch management, when it's trying to stage files, that can also look like lateral movement. Security controls, whenever they are attempting to do domain lookups for things, well, a lot of the time that actually looks like looking before the domain, in which case then that can look like CNC. And then if you've got any PAN solutions in there, this is a bit, sort of more of a bugbear, but whenever you do have admin accounts changed into shared accounts, and then those shared accounts are used, at least whenever somebody was using their admin account in order to log into something, I knew it was them, or at least it was supposed to be them, whereas now if they're using the shared account, you have to go all the way back into the system and try and find out, well, hang on a minute, who actually went and did that? And if those logs aren't being retained for long enough in that system, or you don't have a data lake in order to store them in, you're like, who did that? Well, that's not particularly helpful. Right? That will then trigger you to go and do much more digging into some other security system to try to validate that it was actually okay, rather than knowing in advance who it was. Okay, some takeaways. So high-level concept. Let's say we'll come back to SOAR. Right? So from a good automation perspective, like no tool will guarantee that it can supply you all the information that you need in order to make proper decisions. Like you will have a stable of tools, right, where they're doing lots of different things, but they can all be used together if you just have something to knit them all. Right? So if you get an EDR, if you have a proxy, if you have some sort of AWS monitoring, if you have all these other different tools, right? If you can bring all of those or at least orchestrate those inside of SOAR, well then you're going to be much more able to go and make those decisions from a SOC-based perspective rather than being limited in what it is that each of those individual tools allows you to go into. And you don't necessarily need to jump all the way to SOAR. Like, of all the technologies that are available, I went through, anomaly detection, Gen AI, right? SOAR is probably the one that is more focused towards being good automation, right? Like, if it turns into bad automation, what you're doing, then it's quite intentionally a human has done that. So, that's again back to the human training perspective. But you don't necessarily need to jump to SOAR, right? Because sometimes people think SOAR, okay, well that seems like a whole project and a whole staff and things. Now, there are sometimes you can get workflow engines, and those workflow engines can come from existing tools that you've got. Sometimes they're bolt-on, so you just get them for free because they want you to use the tool. So if some of those workflow engines exist in other tools that you have access to, try that first, demonstrate that worked well inside that tool, and maybe that can make a case for sort of a wider SOAR platform. But SOAR is largely the solution to a lot of this, right? Because it is security analyst or security engineer or security expert driven automation where you're deciding, this is the thing I want to automate, this is the thing I want to go and do, rather than the tool deciding, okay, we'll let that tool at it and it will decide. Right? Another one which is kind of linked to the SOAR component is the advocacy for APIs. Ultimately, in the end, if you're using a lot of security tools and then those security tools don't allow for the richness of the data that you get inside the UI to be exportable from the API into either a data lake or into your SOAR, well, then you're going to be hard blocked on your ability to actually go and do those enrichments or solve those things. Now, that has to be up to kind of us to a certain extent, but businesses to a larger extent, right? Because like at buy time, as our buying decisions, right, I need to make sure that becomes a component of the buying decision. Let me see what your API is like. What data can I get from it? No, not the docs. I need to be able to see what it actually does and then validate that you get the necessary level of information out of there. Otherwise, what you will find is that you will come up with a great theory in terms of, look, I find this thing is constantly sending false positives. So I take the data from over here, because it's in the console, then if I marry that data with this data, then I'll know where it's coming from, and then we can just automate all that away because we know what it is. Well, no, I know the data's in the UI, but you can't get that out of the API, it's just not available. Right, well then, when are we going to have that? Maybe never. Great. So, from that perspective, trying to advocate for the tools that you're using to invest in their APIs, because to a large extent, that API investment isn't a natural thing for them to go and do. It drives you out of their platform, right? But when you want to, then go and put it in just SOAR. So. The other one is being repetition to be in the room, right? I think that is quite important. The security is involved in security tool identification or security tool rollout across the estates. Even if you don't think it's going to be involved, the chances are it's going to come back and do something inside your environment later. So probably want to be in the room whenever that's being rolled out or decisions are being made. And then just, again, to do with expertise, right? So no technology is going to come and save us, right? No technology has yet been generated or yet been provided that is actually just going to do all of this for us. So from that perspective, we all need to be the big blue unit, right? So we need to be this guy. We have tools. Some of the tools we'll have, some of the tools we won't. But ultimately, it's about the skill and the expertise of the specific individuals that are using them that is going to decide whether or not you can solve your false positive problem, right? So don't turn to tools, turn to people. Those are the people we need in order to solve this for us all. And that is the end. I think we have some time for any questions.